Right now, the global race to build artificial intelligence is bottlenecked by a single piece of hardware. Tech giants are buying up these specialized chips in bulk at around $30,000 a piece, just to keep their data centers running. The sole supplier of those chips is NVIDIA. Because of that extreme demand, NVIDIA's valuation has surged into the trillions, and its CEO, Jensen Huang, draws crowds that treat his product announcements more like rock concerts. But this company didn't start in a high-tech corporate lab. In 1993, Huang and two co-founders drafted their initial business plan on a napkin over a meal at a San Jose Denny's. Their goal was incredibly specific. They just wanted to design a microchip that could make three-dimensional video game graphics look better on computer screens. So we have to ask, how did a company built to render polygons for teenage gamers end up laying the exact hardware foundation required for modern artificial intelligence? Back in the 1990s, the computing industry was hitting a wall. Standard computer brains, or CPUs, were struggling to process the heavy math needed for 3D multimedia. The problem was architecture. CPUs are sequential calculators, solving logic problems one by one. In 1999, NVIDIA introduced the GPU. Instead of one pipeline, they packed thousands of simpler cores onto a chip to perform math simultaneously, rendering entire 3D screens instantly. By focusing strictly on solving that geometry bottleneck for video games, NVIDIA accidentally perfected a highly specialized, brute force method of simultaneous computing. The pivot happened in 2006. NVIDIA released a software programming platform called CUDA. At the time, investors were thoroughly confused by it. CUDA was essentially a bridge. It allowed outside developers to bypass graphics completely and use the thousands of parallel cores on a GPU to run general, complex mathematical equations. The first major group to exploit this were cryptocurrency miners in the 2010s. They realized that parallel processing was the perfect engine to rapidly crunch the hashes needed to mine Bitcoin, leading to massive warehouses filled with glowing consumer graphics cards. But the real hinge point arrived in 2012. Researchers entered a global image recognition competition with a neural network called AlexNet. They trained it entirely on consumer-grade NVIDIA GPUs, and they completely crushed the competition. It turns out the deep learning required for AI relies heavily on matrix multiplication, which is just doing thousands of simple math problems simultaneously. That is the exact same math GPUs use to track light and shadow in video games. Without meaning to, NVIDIA's CUDA software had turned everyday graphics cards into cheap, accessible supercomputers, laying the hidden tracks for a massive computing shift. Jensen Huang recognized this overlap early. Years before the mainstream caught on, he pivoted the company's focus, declaring NVIDIA an AI computing company. They began designing industrial-grade chips like the A100 and H100 specifically for data centers, separating this new hardware line entirely from their traditional gaming focus. When ChatGPT launched in 2022, demand exploded. Companies like OpenAI needed massive amounts of computing power to train their language models, triggering a global panic buy of these specific data center chips. Now, competitors are struggling to catch up, largely because of the software. An entire generation of AI developers has spent 15 years writing code exclusively for NVIDIA's CUDA platform, making it incredibly difficult and expensive to switch to alternative hardware. NVIDIA didn't predict artificial intelligence back in 1993. They built a highly effective tool to solve a specific geometry problem, and then patiently kept improving it until the rest of the world realized it was exactly what they needed.